toxins to designing proteins that can solve deep environmental challenges. But like any powerful tool, it presents profound dual-use risks. What if those same AI tools could be used to design novel, harmful pathogens that our current biosecurity systems aren't built to detect? This is no longer a theoretical problem. A recent landmark study led by researchers at Microsoft and conducted in close collaboration with industry partners and the biosecurity experts that you see today on this panel brought this challenge into sharp focus. They proactively red-teamed screening systems using open source AI to design new functional variants of concerning proteins that could evade the screening tools our gene synthesis providers rely upon. But what happened next is just as important as the discovery. The paper outlines a model for responsible disclosure and a rapid collaborative effort between the AI lab and the synthesis industry to patch this vulnerability, dramatically improving our collective defenses. Today, we're incredibly fortunate to have players from all sides of this effort, and we'll be discussing what they found, how they fixed it, and what this landmark case study means for the future of AI governance, biosecurity policy, and the shared responsibility between innovators and industry. Before we dive into the full discussion, I'd like to ask each of our panelists to provide a few minutes of opening remarks to set the stage from their unique perspective. So Bruce, if you'd like to start.
Sure. Yeah. Hi, everybody, and thank you for having me on today. My name is Bruce Whitman. I'm a senior applied scientist at Microsoft, working in the Office of the Chief Scientific Officer. My background is in protein engineering, molecular biology, and artificial intelligence for augmenting those types of applications. I was the technical lead on the study who was running the AI algorithms, designing the sequences, and coordinating between the different groups who were working to patch up their screening software. So obviously happy to get into more of that as this session goes on, but for now I'll pass over to Dean.
Great. Thanks, and thanks to all of you for being here. My name is Dean Ball. I'm a senior fellow at the Foundation for American Innovation, where I write about matters of AI governance and emerging technology. Perhaps relevantly for this discussion, until August, I was in the Trump administration, the White House Office of Science and Technology Policy, where I led the drafting of the AI Action Plan, and also was involved in the revisions downstream of the May gain of function executive order to rewrite the nucleic acid synthesis screening framework, which I think is an important policy framework to think about here. And I should say, when it comes to matters of biotechnology, when it comes to most things, especially biotechnology, I'm a total dilettante compared to my fellow panelists. And I'm in this because I care about it. It's an issue near and dear to my heart from an AI governance perspective, because I think that there's going to be things downstream of AI itself, governance of the AI models themselves, that we're going to have to think about if we want to steer ourselves toward good and secure outcomes with biotechnology. But technically speaking, I'm a moron compared to these guys. Just warning you in advance.
Thanks, Dean. James, I'd love to hear from you next.
Hi, James Higgins. I'm Vice President for Policy and Biosecurity at Twist Bioscience. Twist is a DNA synthesis company based on the West Coast of the US. And I also chair the International Gene Synthesis Consortium, the IGSC. So that's an organization that collaborates across 40 different organizations in 10 countries on biosecurity approaches in gene synthesis.
Last but definitely not least, Adam, yeah.
Hi, my name is Adam Clore. I'm a principal scientist at Integrated DNA Technologies. I've spent most of the last 15 years developing new tools and processes for synthetic biology, and involved in that for most of that time with James here, have also been involved in our biosecurity screening and the policies that we use that govern that biosecurity screening.
Thanks so much, Adam, and really appreciate all of our excellent panelists coming here today. Bruce, I'd love to just start with a question for you. So this paper frames the vulnerability that you discovered as a biological zero day. And I'd love to hear if you could walk us through your decision at Microsoft to conduct this red teaming effort. What was the process like for initiating the study and responsibly disclosing the findings to the screening companies to avoid enabling bad actors via public disclosure of this info hazard?
Yeah, so Microsoft actually has a large number of researchers working in chemistry, biology, and related scientific fields. So it's not totally out of our wheelhouse to be working on problems related to biology. It's not like we just picked this up at random. In fact, my boss, Eric Horvitz, was organizing a meeting at the University of Washington that was related to security in the face of artificial intelligence advances, particularly for protein engineering and protein design. So given my background, he asked me, hey, in preparation for this meeting, is there anything that's top of mind that we could just demonstrate as a talking point? And so that's kind of where the idea was born as to sure, let's try and use these open source models to demonstrate a potential malicious activity that somebody could use. And for me, it worked better than I thought it would. And so that what started as kind of let's just have this example became this large project. We outline a lot of the procedure that we followed in the paper, but just briefly, once we knew or had a sense of what this problem was, we talked with Adam, we talked with James, and other folks who were using these types of tools, or who relied on these types of tools to figure out an action plan, figure out how we would move forward with patching things appropriately and making sure that the right people had the knowledge while this was still a vulnerability.
Great. Thanks, Bruce. Well, obviously, this study has been a landmark contribution, and I think it's just really impressive that that Twist and IDT, James and Adam, that your companies participated in this study very collaboratively and in an open way. What was it like to be a part of the study for you, and how did your organizations validate the vulnerability and then prioritize the development and deployment of the patches to your screening tools?
I can start with that. You know, as Bruce mentioned, this did work much better than I think any of us had thought it would, and so it was very concerning for us to see when this was brought to us, and we tested this in our standard screening processes, and saw that by and large, most, if not all, of the sequences got through the screen. That was very problematic for us. That immediately, moved this into a project that was something that was very high priority for us here at IDT, and really gave us the impetus to really begin this collaboration, or at least participate in this collaboration, and patch these things and get something that worked much better than what we currently had.
Maybe I'll just add that we're grateful that Microsoft took an interest in this problem, and they were an excellent partner. I imagine there could have been a whole host of actors who could have tried something like this.
Yeah.
And so to have Microsoft approach us, have us work out this sort of CERT-like process of limited disclosure until we had mitigations, I think all of that was incredibly productive. And the IGSC companies have been working on this kind of problem since 2010. And so this very much was kind of a continuation of the efforts that the companies in the IGSC have been working on. And it was great to have a partner that had the background and skill set on the AI side.
Well, very, very impressive. Really grateful to have y'all's participation and eagerness to solve this problem. Before I get to my next question, we'd love to see questions in the chat. Please, if you're an attendee and have a question that you have for our panelists, please feel free to put it in there starting now. Bruce, one more question for you. So the study here used open source AI models. How much specialized expertise do you think is truly needed here? Are we talking about a nation state level capability, or is this something that a more well-resourced individual could reliably achieve?
I think there's a lot of nuance to understand that kind of underpins that question, because there's a big difference between being able to use the tools and being able to use the tools effectively. So I would say anybody with a basic understanding of protein engineering, so probably undergraduate level biology, could use these tools. Now, there's a big difference again between being able to, just get them to do anything and be able to use them in some capacity. I would say, though, largely it's an open question as to how well somebody could use these tools downstream. We assume not very well, but there's ongoing tests to see actually how well or how capable are people who have never seen biology before and have never really interacted with it. How capable are they of using tools like this?
Makes a lot of sense. Well, thanks for sharing. James and Adam, another question for you. So the patch tools represented a massive improvement, catching about 97% of the more probably functional proteins, but 97% is not 100%. And the paper suggests that these misses were in a gray area with high similarity to non-concerning proteins. So how do we solve this gray area problem?
I guess first I'd say that the tools that are in use or that were in use prior to this activity were designed to detect what we know to be harmful. So that was the design philosophy behind those tools. They weren't designed to detect this kind of increased sort of cloud of things that might be harmful. And so this project was really helpful in that regard to tell us kind of what does that cloud look like in terms of the degree to which the sequence can vary while the structure might remain very similar. In terms of those 3%, I think of them indeed as gray area, not just that they fall between a known pathogen and a known non-pathogen, but that we don't really have a good understanding of how to predict the role that that protein would play in a biological system, whether it would recreate the role that the pathogenic protein plays or that it would recreate the role of the non-pathogenic protein and what the implications of that would be on biological risk. So I think it just calls out that there's a lot of work to do for the broader biosecurity, biosafety community to better understand these kinds of differences from these kind of well understood proteins and how that reflects on their ultimate function.
I would agree with that, and just just add slightly that our ability to design proteins has gotten pretty good. There's a big step between designing proteins and actually making functional proteins and having those available physically. And so there's a bridge there that hasn't been gapped yet. And I would put a lot of emphasis on the yet.
Yeah, and I just want to add to my response because I think what Adam's saying there, it extends that nuance even further, right? Can you use the tools? Can you use the tools effectively? And then can you translate the outcomes of those tools into something real? And there are massive roadblocks at each one of those steps.
Makes a lot of sense. We'll certainly hope that remains the case. I'd like to turn next to kind of the future of governance, especially as it relates to screening. Dean, you spent some pretty meaningful time in the White House during a lot of the rollout of a lot of really interesting policy. You've been at the center of AI and biosecurity policy. Could you discuss the administration's key actions, including the president's May executive order on improving the safety and security of biology research? And looking beyond that, I'd love to hear from you what you see as the most critical next steps and remaining gaps that government and industry must take.
Yeah, absolutely. So I think first of all, one thing that is maybe underappreciated about the president is that he thinks a lot at a personal level about tail risks, about catastrophic tail events. And you can hear it in the way that he talks about the risk of nuclear war. You can hear it in the way that he talks about the risk of bioengineered pandemics. And this was true before COVID. And then, of course, he has the experience of having been president. And many people in the administration today have the experience of having, been in power in the initial response to COVID. And so biosecurity is sort of kind of deeply in the DNA of I think various people's thinking in the Trump administration. I use DNA there in a way that perhaps I shouldn't have. But so the way that this manifests itself in policy is a few different ways. First of all, May 2025, as you referenced, Scott, the president signed an executive order on dangerous gain of function research. So this was primarily about adding research security protocols to federally funded research that involves gain of function engineering on pathogens. Now, in addition to that, sorry, one moment. Sorry about that. In addition to that, in that sort of tucked into that executive order was a provision about revising the nucleic acid synthesis screening framework. To this audience, that will be a familiar document. To most, probably not. But this is a framework that started in the Biden administration. It's a framework that I personally, despite being on the other side, praised when it came out from the Biden administration. I think it was a wise move. And basically what the Trump administration was trying to do there is add an enforcement mechanism to the synthesis screening framework. So right now, the current status quo is that using federally funded principal investigators and other researchers need to use nucleic acid synthesis providers and benchtop manufacturers that adhere to certain guidelines laid out in 2023 by HHS. Those guidelines are still in effect, basically relating to both KYC and screening of synthesis of potential of nucleic acid syntheses. The problem, though, is, as I alluded to, there really is no accreditation or enforcement mechanism. And so what the scope of what we were trying to do, and the policy is not out yet, so I can't comment on what the final policy is going to look like, though I do anticipate that it will eventually come out. But the scope of it was really to add a layer that would make sure that the providers are actually doing this work to some level of robustness. Now, all that being said, I can tell you that I and others who were involved in the drafting of that policy were quite cognizant of the fact that these kinds of flaws in the screening methodologies are latent, and that we need much better screening going forward. And I think right now this is a question that many people in the Trump administration still don't feel is answered. And so, I think this is one of the most urgent areas to work on. My view, and this is always my view, so it shouldn't be that much of a surprise, my view about many matters of governance, is that this requires a kind of technological and scientific innovation that is going to be better situated to originate outside of government. And, it could be something that is adopted by government eventually, but I will say that the R&D priorities of the Trump administration include screening for potential functional-based screening and other advances in synthesis, nucleic acid synthesis screening technology, for this exact reason, because we know that this is an unanswered question. So I think that's kind of where I'll leave it. I have a lot more thoughts on where we should go from here. Well, I guess I'll very briefly just say, in terms of where I think we ought to go, to some extent, I alluded to it. I think that there's some, potentially exciting startups and also sort of startup nonprofit philanthropic ventures that are plausibly quite interesting here. And I also think that there might be room for activity to codify this in legislation, either at the federal level, optimally at the federal level, or at the state level, because the nucleic acid synthesis screening framework is it's not a legally binding document in some sense. It's not policy. Well, it is policy, but it's not a law. It does not apply in particular. It uses procurement as its hook. So it's the federal research that's the hook. It's a regulation, technically speaking, on federal researchers that but really it's a regulation on the providers, but you can't actually directly regulate the providers from the perspective of federal procurement. So there's lots of private companies, there's lots of startups and others that are not subject to the nucleic acid synthesis screening framework at all. And I think that there's quite possibly room there for legislation that makes that happen. Again, either optimally at the federal level, but I think if need be at the state level.
Thanks, team. Well, we really appreciate your service and contributions on this critical issue and for keeping Americans safe. I want to remind our attendees, if you have a question for one of our panelists, please put it in the chat now. We'd love to hear from you. My next question, Dean, you're welcome to weigh in on this, but I'd love to hear from really anyone here. So this study was a successful voluntary collaboration, as Dean alluded to, between a major AI lab and key industry providers. But to ensure rigorous screening standards across industry, again, as Dean sort of spoke to, we think at ARI that it will be necessary to require all providers that they screen for both customers and sequence orders. So what steps do we think that Congress and the administration needs to take to protect national security and public safety?
Oh, this is for Adam.
Adam, feel free to start, and then we'd love to hear from
Sure.
you. Yeah.
Okay. I was going to agree with you, Dean. I think government is not the best place to institute the nuance of the policy here. There's a lot of technical minutia here, and this is a moving target. AI is rapidly changing, and so the policy is going to have to change and respond rapidly to the innovations that we see in the next few years. So that's where I think the development of this plan, is better suited for things that come out of academia and the industry, where we can move very rapidly and very agile. But I do think that the enforcement of this and the mechanism to control this needs to live in, ideally in the federal government. So this has been an effort that the IGSC has long sought to develop it and come up with ideas and mechanisms that will work from a scientific and technological point of view, but the implementation and the enforcement, particularly of these policies, needs to be outside of those areas.
And yeah, I'll say the IGSC has been working to produce with the National Institutes of Standards and Technology test sets and other mechanisms for measuring how well biosecurity screening systems are working, and working to plug that into a framework that government could sort of pick up as sort of third-party verification that companies are screening effectively. So I think those are useful inputs into a legally mandated requirement to screen orders and customers.
Yeah, I think that's exactly right. I think the technical side of this probably is driven by the private sector in collaboration with an organization like NIST, which has done very solid work on this issue. And then you sort of codify it in policy. And I think another interesting area to think about here that's maybe, I think it's fundamentally a stopgap measure, but it's something that is worth at least pondering, is insurance. What is the role of insurance in all of this? I mean, I think the general issue of liability for these kinds of things is somewhat underexplored. Like, people think that AI liability is an underexplored area, but I think this is like truly the Wild West. I think we have no idea, particularly, if you obviously pandemic scale stuff, insurance doesn't really work because it dwarfs the risks, the harms dwarf the balance sheet of everybody. But for sub-pandemic scale stuff, I think there's very plausibly agricultural epidemics, things like this. There are situations where, I think we don't really know, as far as I know. And so this is an area where I tend to think not only that policy development is potentially useful, but also just considerably more of research might be helpful.
Great. Thanks so much, everybody. Well, final question from me before we turn to audience Q&A. So the paper's conclusion towards the end is pretty stark. It says that sequence-based screening alone is unlikely to remain sufficient, as AI designs proteins unlike any found in nature. It suggests solutions like homology detection. So could somebody here, maybe Bruce, could you translate that for us? And what does the next generation of biosecurity screening actually look like?
Mm-hmm. Yeah, so homology detection actually, it's a big catch-all term. What homology means is evolutionary relatedness. So right now, actually, what is being used is a form of homology detection. What we really need to be moving toward is something that is function detection. So homology is kind of a proxy for function, but obviously it breaks down at a certain point. So the tools that are in use now are largely based on what we would call sequence identity. So without going into the real details of what that means, it's how similar are two DNA sequences to one another. And the way that these AI techniques for getting around the existing strategies work is they make the sequence identity very low while keeping the function the same. So what we need in the future, as we're expecting these protein design tools to get better and better, meaning they can go further and further away from known protein sequences and develop things that look nothing like we see in nature, we can't rely on that assumption anymore of close sequence identity. And we can't rely on that assumption of homology either, because it might not have an evolutionary relative. It might be completely distinct in the space of possible proteins. So really what we're hinting towards at the end is a future proofing, that there will be a point where we can't rely on sequence identity alone, and we need to move to alternate strategies.
And
James,
maybe
feel
I'll
free,
just,
yeah.
put a plug in here for we've talked about moving maybe towards function-based screening. So you're sort of looking at a sequence and how it'll fold into a protein, and then trying to estimate what it would do in a certain context that you might care about. And I think that really is kind of a goal that we all need to start moving towards. Right now, a lot of the biosecurity screening is built around trying to identify stuff we just know happens to be harmful in nature. And that has worked really well for the past couple of decades, but we're really going to have to move toward what is it that we think is harmful, and how do we recognize those things in a very noisy background of totally legitimate science. And I would also point out that this is a difficult problem because the vast majority of orders are entirely legitimate. It's not like cybersecurity where you have a lot of actors who are trying to cause problems or break systems. That just doesn't happen here. And so we have a very, very low frequency, potentially zero, of people trying to misuse these products. And we have to design systems that are accordingly sufficiently accurate to detect that.
Yeah, it's fighting like finding a needle in a haystack. It's a tricky problem. We have a question. I'm turning to audience Q&A now. Feel free to put any in the chat here. We have a question from David. So the paper explores mitigating misuse through screening conducted by DNA synthesis companies. Do we have any expectations or thoughts that folks on the panel can share about what will happen as DNA synthesis technology proliferates, and how will AI accelerate this process? I think this might be referring to benchtop synthesizers.
Benchtop synthesizers have been around for multiple decades now. So the proliferation has happened for a long time. They are definitely getting better, and the ease with which we can make very long sequences that are long enough to be, biologically functional, is something that is changing. But again, there's a large difference between making something in software and making something in real life. So there's a lot of challenges there. And I think what I worry about and what keeps me up more at night isn't the proliferation to a large number of people, but small groups of highly trained and highly skilled people, that already have access to DNA synthesis and to protein production, and what they can do with things. So I worry less about the proliferation. I worry more about the state of the art and the technology that is being developed here.
And I would also maybe add the 2024 framework that Dean referred to explicitly calls for benchtop synthesis devices to be held to the same standards as centralized screening providers. So those devices, when sold on the market, should be capable of screening the products that they make to determine if the user is requesting that a pathogen be made. That is a much harder problem on a device, and so that is a challenge for the makers of these devices. But I think it's appropriate in terms of asking those manufacturers to ensure their devices are not subject to misuse.
Great.
I also think that we have to remember that the framework is U.S. policy, and this is an international problem. So we need to always think beyond the borders of the United States when we're considering risk with this.
That leads me perfectly to my next question. Yeah, I would love for the panelists to address internationalization and regulatory harmonization across jurisdictions.
Yeah, so I would say, first of all, totally agree. Um, I think America has the benefit of being something of an early mover on the specific issue of nucleic acid synthesis screening. Um, and so, and a large presence in the market and all the stuff that's typical of American policymaking. And so I think simply by having the standards, that's one thing that helps a great deal. Part of the reason I do like insurance is that insurance has an ability to move across state lines. But of course, I think something like this must be paired with diplomatic efforts. And I can tell you that, when we were working on the biosecurity in general and nucleic acid synthesis in particular, um, you know, we had we were thinking about the diplomatic strategy from the ground up on that. And I can say, there's only so much I can say publicly about, sort of conversations that have taken place. But I will say that conversations, with starting with allies, starting with the low hanging fruit, have taken place. And I hope they continue to take place. Um, because I think it's actually a relatively easy ask in many cases to get other countries to adopt similar standards, particularly because American, either the U.S. government or American entities, firms, and philanthropic ventures, and all sorts of things, will be doing a big chunk of the hard part. So all you have to do the standards building work and the technology work, and so uh, um, I think it's a somewhat easier sell, but in the long run, this is a matter of global policy import, and I hope that it's a part of diplomatic strategy going forward. I think it can be.
And this is part of the value of both the IGSC's efforts as well as our efforts with NIST. So these can easily be fed into ISO standards in terms of the technology piece of how you measure the system to know if you're doing any good. And then on the international governance front, you've got the UK government that has put out a guidance document that's very much in line with the US. In the EU, they're discussing a Biotech Act now. There's been some advocacy for including similar language in that set of legislation. So I do think there is willingness, as Dean said, on the part of other governments. And the more we can provide kind of ready-made systems for verifying these practices, I think the lower the bar for accepting that requirement will be.
Thanks, James. And I know that IGSC's work on this has been critical and made it a lot easier for different jurisdictions to make progress on this topic, which we want to see continue. I'd love to hear from James and Adam as well about kind of screening efforts and how can we make this as easy as possible for companies to comply with. At ARI, we really value and want to support the American biotechnology industry, and making this easy to comply with is a critical part of that.
The biggest thing that I worry about, if I reverse the question a little bit and think about what makes it hard to comply with, is localized jurisdictions making up their own rules. So it would worry, I think, all of us if there's 50 different sets of rules, one for each state that we have to try and comply with. So doing things at a federal level and then integrating that federal level with organizations that are international so that we have one set of rules that everyone can work from is, I think, the first step. As James has mentioned, the IGSC is working on standards that we can use and also test sets that we can use so that as we bring new members into the IGSC, we can validate that they are effectively screening, and we can also periodically reevaluate people to make sure that they're holding themselves and that we're holding them to the same standards. I think those types of mechanisms make it an easier barrier to entry. And it also helps out a lot of the companies like Twist and like IDT that have been spending a lot of time and effort, screening and making sure that we're screening in the right way. It holds everyone to the same level if we can have these standards in there. And that's really good for the market in general.
And maybe I'd also put a vote in for right now, governments generally establish regulatory controls on the species level. So they'll say this virus or this bacterium or this fungus. And really what we get asked to make are actually parts of those organisms, so individual genetic components. And so really coming down a level and agreeing as a community where the risk exists on the component level, and providing that clarity to the gene synthesis industry, I think would be incredibly helpful. And we do have some ongoing work with IBIS and an organization called SBRC, the Sequence Biosecurity Risk Consortium, that's been stood up to try and address some of that. And the hope there, in line with Dean's suggestion of taking some of this into the private sector, has been try and come up with community consensus about what these components are, and then kind of push that up to governments and say, look, here's what the science says. Let's set the regulatory controls on these things, and then have a process going forward for revisiting that.
Thanks, James. We've got a great question here from Seth, addressing what I think is called the split order problem of, what if a bad actor could go to one company and order half of a sequence over here and a different company over here and order the other half. So Seth asks, isn't it pretty trivial to just order shorter sequences? They're too short to be screened, but can nonetheless be assembled. I'd love to hear from anybody.
I can start on that one So, I mean, I feel like my answer is always there's nuance, right? So yes, it is trivial to order small fragments from lots of different companies and then assemble them, but that's a lot of work to do that. Notwithstanding the fact that we have done follow-up work on those types of small fragments and found that things are still detected anyway. So it takes one company with an appropriate screening tool to find those fragments, and it's going to be very difficult to reassemble them unless you have expertise in molecular biology. So the answer is, from my point of view, yes, it is trivial to do that, but it's not exactly a useful strategy. It's not something that you would use in place of some other approach. But I do think this also gets to a bigger problem, which is maybe what this question is getting at is what do we do with all the routes around DNA synthesis screening? Because there are plenty of routes. And I think Adam and James have a lot of thoughts there, and Dean, you may too. But the answer is ultimately we can't rely just on DNA synthesis screening alone.
Yeah, I completely agree. We cannot rely on screening alone. I think one technical matter that's worth noting is both the Biden era policy and I suspect where the Trump administration is going to go will gradually lower the nucleotide threshold from 200 to 50. So that helps on the margin. It doesn't fundamentally solve the problem. Ultimately, I suppose, you could just go nucleotide by nucleotide if you really wanted to, and then just stitch them all together. But then, right. I think it is, the ordering is non-trivial, but as Bruce said, the actual stitching together, might be, sort of a much heavier lift. I think it's like, from a policy perspective, government is this like sort of enormous enterprise in risk management in some sense. And, we would have this conversation all the time in various policymaking processes, not just this one, where you have to come down to, what level of risk are you willing to tolerate here? And I think, nucleic acid synthesis is not the only area, but there it's like, okay, well, we have sort of a multi-layered approach on synthesis. We also have, an approach on the models themselves, at least to some extent, already happens. That's already basically happening through typical market and liability incentives from the frontier labs, who do things like they have classifiers, they have various kinds of guardrails to keep the models from outputting dangerous things like this. There might have to be more such things down the road. We'll see. But all of this will evolve. And I think the risk level will never be zero. You'll never have perfect solutions to this. If something like that did become a problem, one thing that's interesting, one thing that when I was thinking about synthesis screening, one thing that just kept coming back to me is how much this problem feels a little bit like fraud detection in financial services. Like I just kept saying to myself, like, man, what we need here is Stripe. Uh, like what we need is like, Stripe is sitting at the middle of, trillions of dollars of digital commerce, and they've built these very sophisticated analytics, machine learning models that are able to determine all kinds of subtle things. And, the answer is not always just like, this is fraud or it's not. Sometimes it's like, well, this is maybe fraud. And we're going to inject a little bit more friction into this transaction so that we can have a little bit more security. And maybe we'll inject a little bit more friction. And then, eventually we say no or we say yes. But there's all kinds of gradations you can do. Obviously, something Stripe exists because there's network effects associated with doing this, and there's a lot of economic value to be provided in facilitating trillions of dollars of transactions. I don't know that nucleic acid synthesis will ever be like that, but I'm also, at least you have an institutional way of thinking about how such a thing might work. And do you eventually need there to be some sort of centralized clearinghouse, some sort of screening service that everyone has to call to? Maybe that's the eventual institutional evolution of something like this. I don't know, but I think it's worth at least considering.
Thanks, Dean. Got a technical question next from Jonathan at EBRC for Bruce, James, or Adam, I think. So how is it possible to implement function-based screening in this context of novel proteins if you need functional data to confirm or deny that? Would this just be a guess to start a conversation with a customer?
Yeah, no, that's the main problem that we're running into is predicting function. It was just last year that the Nobel Prize was awarded to scientists, in basic prediction of function. And this is much more detailed. In my mind, this is not a narrow AI question. This is a general AI question, because predicting function has to predict it within the context of the biology that it's being used in. And so you don't just need to know how the protein functions, you need to know how that protein interacts with the rest of the proteins in the cell or in whatever organism it's going to be affecting. And so it's a very complicated problem. It's not something that we have an answer for right now, just I think, to be blatantly honest. Yeah, I'll leave it there.
And maybe I would add to that there are important norms and in some cases laws against creating variants of known weaponizable toxins and seeing whether they get more or less toxic. And so in some cases, it's actually very difficult to figure out appropriate ways to generate the data that you would use to then train a model to determine whether a structure is capable of causing the kinds of harm that you want to predict. So I think there's a social problem that we need to address in terms of that data generation. And then also to Jonathan's other point, I don't think it's necessary to have models that are 100% accurate. It is really important from the gene synthesis standpoint to just say, could this thing in some way be equivalent in function to this other bad thing? And then that does kick off a conversation between us and the customer to make sure that they are legitimate and that they understand what they're ordering. So it isn't that we have to totally boil the ocean and solve this problem. We just have to have reasonable predictive power in narrow domains that we're most concerned about.
David has a very fun and cheery question here. So which actors here are of chief concern? Major powers, rogue states, small groups of terrorists, or homicidal groups? Or is accidental catastrophe here the biggest concern?
In my experience, it really depends on who you talk to. And actually, the first thing that you need to do whenever having a discussion about any type of risk in AI is define what actor you're talking about, because the surface you're talking about really changes in that case. So for me, for instance, my fear, or the group that I worry the most about when it comes to biodesign tools, so these domain-specific tools like the ones that we use in the study we're talking about here, the main group I worry about are what we would call the novice actor. It's somebody who doesn't have prior exposure to biology or chemistry. It's somebody who, sets up a home lab in the basement, something like that. The reason I worry about that is because from my point of view, other actors don't necessarily even need the tools. They don't need the assistance from AI in the beginning to be able to launch some of these attacks. But a novice probably would. They'd probably need coaching. They would need more assistance. And also, there are just far more novices than there are experts. So it's a bigger pool of people to worry about. But of course, that's the view that I'm taking. And there are very reasonable arguments for otherwise, for focusing on other groups. And so, back to what I said at the beginning, it really depends, I think, on your background, what you're thinking about, the domains you're exposed to, how you would answer that question.
And I think one of the things I want to reiterate is like actual weaponization is hard. To create a effective biological weapon is very difficult. It is not an issue of just getting access to the DNA. And so one of the factors we worry most about is someone doing something that isn't all that harmful, but sounds very scary. And that, humans are very good at telling ourselves stories. And so that spreading like wildfire and having like profound policy implications on, for example, uptake of biotech in the United States. To me, that's a much bigger threat than like an actual weaponization scenario. And we try and defend against both of those polar extremes. But I do think that is something that isn't often mentioned in terms of threats.
Very important point, James. Thanks so much. Dean, a question here for you from Jason. I would love to hear from you how Republicans and Democrats currently approach this topic. Is this a very partisan issue?
It's a great question. I hope not, is my answer. Biosecurity absolutely should not be a partisan issue. And to the extent biosecurity becomes considered, has a nexus with AI policy, that nexus shouldn't be partisan either. I'm fine. We can throw food at each other about woke artificial intelligence and bias and misinformation and all this kind of stuff. But biosecurity is just like, there's no point in having a government if we can't manage something like biosecurity. We should just throw the whole thing out and start over if we can't competently manage this issue. There truly is. I mean that quite seriously. From like a political theoretic perspective, I mean that. There's just no point. The nation state has failed if we can't do this. So I think that unfortunately, with respect to AI, not so much on biosecurity proper, but as it becomes an AI issue, does AI pose risks? Does it not? Do we need to worry about AI governance? Is AI regulation ever going to be a thing? These kinds of issues. They ended up being fights like 2 years ago about future capabilities of systems. At the time, the systems didn't pose very much novel bio risk. Now they're starting to, and I think the direction of travel is quite clear. My view is that shouldn't be a partisan issue. In some ways, it's a partisan issue. I don't think for that many people, and I really hope that gets nipped in the bud because it really ought not to be.
Thanks, Dean. And your work has been obviously a really large part of that. We've been really pleased at ARI to see great work on this happening in the current administration, the previous administration, and from bipartisan leaders on both sides of the aisle in the House and Senate. So thank you so much to our attendees for your great questions. I'm going to turn now to final statements and would love to give our panelists the time to just very briefly sum up any final thoughts they might have. Adam, why don't we start with you?
Well, I would say, I'm very proud of this paper and very happy with all the work that went into it. But, the thing that really stands out to me is as the accomplishment that we have here isn't that we made, we found this vulnerability and we fixed it. No one buys, antivirus software for their computer and then never updates it. That's a good example of this. And this is exactly the same way. This is a moving target. And what really came out of this that I think is powerful and meaningful is the collaboration that we've started. And as James has mentioned, the other workshops and groups that we have that are continuing this work so that we can continue to fight this arms race. And I'm very excited. I'm very hopeful that these groups are going to be able to affect a large difference in our safety.
Thanks, Adam. James.
Yeah, just thanks to ARI for holding this. I think biosecurity screening has been kind of an ongoing work in progress for the past 15 years. That continues to be true. I think the work that's represented by this paper is a great step forward, but it really also represents a future pattern that we really have to kind of lean into, which is recruiting organizations with a ton of expertise in AI who can help us to figure out how to scale these systems to keep pace defensively with the capabilities represented by these biodesign tools. And so I think it's a great template, but I also invite any of those wildly talented AI companies who are interested in this kind of problem space to get in contact with the IGSC and help us out.
Thanks, James. Dean.
Well, I just want to thank you all again for attending this. This is an incredibly important issue. I think that the big challenge that I think we face with these sort of emerging technology governance issues is that in some sense I think we will need new kinds of institutions, which aren't just organizations, but entire structures and ways that organizations relate to one another. I think we'll need new kinds of institutions to deal with problems like this in the limit, as these technologies really diffuse, as sort of synthetic biology becomes far more powerful, and we are taking baby steps right now. And I am very cognizant of the fact that we're taking baby steps. And sometimes my approach is like, start with the baby steps and then also think about the long-term goal and then try to eventually marry the two. We're in the very early stages, and I hope that we can make progress on this issue on the legislative front and otherwise in the next 12 months.
Thanks, Dean. Bruce, please close this out.
Yeah, well, I want to echo what everybody else has said in their closing remarks. So, in lieu of just repeating that, I do want to add that it's very easy for topics like this to be blown wildly out of proportion. So I want to close basically by saying this is important work and it will be continued work, like everybody has said, but the sky is not falling.
Thanks, Bruce. Really grateful to all of our panelists. Thank you so much for your time here today. This paper truly represents an enormous contribution to the field, and very impressive to see not only this discovery, but impressively the voluntary collaboration that we saw here. Really grateful to your attendance and your thoughts. Thanks as well to all of our attendees for paying attention and using your time to listen to this conversation today. We hope to see you again in the near future.